Okay, hey, how's it going? Gonna continue with this OS series here. We're gonna continue where we left off. I want to make like a little kind of file table type thing and probably structure our project a little bit better just to start off. So what am I gonna start off with today? Well, I actually have notes, which is good. I'm gonna basically go off my notes and cut out awkward pauses and things and post editing. But yeah, I'm gonna restructure my our folders here a little bit. I want to rename our folder to CaseOS. Can I do that? Okay, that worked. It just doesn't give me tab completion in this. That's nice. That's always nice. So if we do Q, all right. So we're on CaseOS. We have our source. I'm going to make another folder here called a bin. So now we have source and bin. I'm going to put all our compiled binaries into this bin folder, and I'm going to put the sources within the source folder and a tree hierarchical structure to kind of make this a little bit better. So our print functions I'm going to put inside source print, just for the moment to make things a little bit more structured in my mind. Better than having like, you know, because we're going to reach 20 bin and source files. I don't want that all in one folder. That's just going to be annoying. So I really don't want to deal with that. But anyway. So we have all these in here. Old is just, the old folder is previous boot sector stuff that I was working on before the current episodes, just for making sure I kind of knew what I was doing, which, yeah, well, you see how well that works out usually. But I don't need that folder anymore. For our print stuff, I'm going to move into the print folder. So let's move everything that starts with print into the print folder. Subdirectory of itself. Oh, because it's a, yeah. Because I named it print. Well, let's move everything with the underscore print into the print folder. And I did not want to turn override off. I thought it was on. So that should work. No such file. Oh, it already did. It just couldn't move the folder into it. Okay. It stopped. All right, so that's in there. I can move assembly into its own assembly directory, or an include directory, I guess. I don't know. We'll do it in the assembly directory. So let's move everything that ends into assembly into the assembly directory. Okay. So now we're just left with our binary files. I'm gonna move everything there into bin. All right. So all we're left here is with assembly and print, which is good. Here we have bin and source. All right, so within our bin, I'm also going to make a Makefile. All right, because since we're concatenating these together, in case I want to put more things in here, which I'm going to do soon after this, we'll be doing, like, to make the actual files, we'll be doing, you know, FASM in the file names. We'll be catting, you know, whatever files into our output file. And I don't want to type all that every single time, so I'm going to use a Makefile. Haha. We're going to be, you know, part of the 21st century here, I guess. And it'll be good. Then we can use make, and we can use the Makefile. Of course, there's nothing in the Makefile, so it doesn't do anything, but that's nice. That'll be a way of improving our build here. I'm not doing any CI, whatever, continuous building stuff, but I'll use a basic Makefile for this project. Try to keep it a little bit simple. We'll do that. All right, so how do you use a Makefile? Well, you give it like a target. You give a target object that you want to build. So in this case, let's say we want to make our os.bin. We do this, and then we give it the objects that are required to build this target. So at the moment, what are we using to build our os.bin? We're using our mic that we keep bumping. We're using our kernel.asm file, and we're using our bootsect.asm file to build our output.bin file there. So this is right. You do this, and then you have to put a tab space here in order to for it to actually work. You can't use spaces in a Makefile. It's very picky. I believe you can't use spaces at least, but I'm going to use tabs just to be absolutely sure. These are the things that go into making the object, the prerequisites you need to build the object, and this is what you use. You do a tab, and then you say how to build the object using these prerequisites. So how did we make this? We're using cat. So I'm going to say cat bootsect.assembly space kernel.assembly. I would put it into os.bin, and that's basically all you do here. Now if we run make and we do make os.bin, then it will do this. Or we can, well, we don't need the bin here. We can do make os. We can do os with these two, and it'll make this into os.bin. Other than that, I think it's a pound sign to do comments. But then again, in order to make the OS, we need to use the other two files. So we need to tell it how to make the other two files, which at this point is really simple, but still. Bootsect, I guess. Bootsect.asm. We don't need anything to make the bootsect.asm, I don't believe. All right, for it to actually see that as an object that we need to make. So how do we make that? We're just running phasm on it. So running phasm on our bootsect. Well, this is to make the bootsect.bin. Bootsect.bin. That means we do have to run make on make bootsect.bin, but we'll run phasm on this and it'll make that. These aren't correct at the moment because the file paths aren't right. I'm just writing this down first so I know where to go. And to make our kernel.bin, we do the same thing. Use a tab and we'll do phasm. So I'm using phasm kernel, not assembler. Okay. So if we run make OS, it should use these two, and to use these two, since we've labeled them inside our Makefile, it will run this for this prerequisite. It'll run phasm, generate this, then it'll run phasm, generate the kernel.bin. It'll use these two to make this by doing the cat here. This should work, I believe. Okay. If it doesn't, then I'll fix it, of course. And then I'm also going to clean stuff up, I'm going to make I think what's people use for clean, make clean, and this will just, when we make the file paths right, I'm going to remove all the binary files so that we can start from a clean slate with only the source and everything. Okay, and that's our basic Makefile. We'll save it. So we have our Makefile here. We have os.bin, which will be made from, well, if we can run make clean now and it'll get rid of all these three. But if I remove the os.bin and I do make os, it will concat those two into os.bin. So make os. No such file or directory. Oh, because I'm using the assembly files. Duh. So it wouldn't be a Queso stream. It's not even a stream. It wouldn't be a Queso recording if it wasn't, you know, mistakes weren't being made. So that's okay. All right, if we make OS now, it'll make, yeah, it'll run, it runs this for this using these. If we look, we have os.bin. So that's nice. Now we don't have a .box file in this. We do need to still get that. Let's go into our source .box. Yeah, let's move our box source into our bin. Okay. So we need to move that just to make sure. So now if we run box, it'll do the same thing. I do alt tab. Yeah, okay, it works. All right, just making sure. So if I run make clean, it will remove these binaries, which is, you know, that's nice. And then we just left with the make file. Okay. So let's, this is in our bin file here. So these things will be in the bin. This will be all right. Now bootsect.bin, it doesn't know where this is at the moment. So we have to give it a qualified file path so we can actually find it. That would be nice, right? So if we're in the bin, it'll be in one before, and then in the source, and then in the assembly, right? Is where I put these. Yeah, that's where these are. Okay. And this one will be in the same path. I'm using relative file paths at the moment, which might not be great, but oh well. It's fine. Kernel assembly, it'll run those, it'll make those inside, well, it'll make them inside this actually. So we might want to do a move here. Let's move, I don't know if I have to do a tab every time. I feel like I do though, so let's move. It'll make those in the file by default, so let's move our bootsect.bin into, one up would be source, another one up would be caseOS bin. Okay, and then we need to do the same for our kernel, for our Gerbic kernel. Kernel, how do I use a Makefile? Oh, that's a good gamer joke. People like references, right? Going all Metal Gear Coder here. I'll call my OS Sahelanthropus. No, I'm not going to do that, but there we go. So that should, it'll run multiple commands as well, make will. So it'll run phasm on this file. Since this Makefile is located in this area, it'll run it for this, make the binary, move the binary into the bin, which is where we're at. It'll run it on this, move that into there. Okay. I think we have to qualify these because the Makefile won't see it over there. So let's do that as well. Source ASM. All right. Source ASM. Okay. I think that'll work, and that'll remove the binaries here. So let's see if we do make OS, because at the moment I don't have anything here. We only have the Makefile, so we do make OS. Cannot move, not a directory. Nice. Awesome. Oh, we can just move it into its current area. Ah, you see. We just move it into where we are now, which would just be dot. Gotcha. So dot would be the current directory. Since we're running the Makefile from this directory, want it to be in this directory, we can do this. My power's flickering, which is nice. And then that should put them into here. Okay. So what do we have in this folder now? Still just Makefile. So let's do it now. I didn't save this. Okay. Let's do it now. There we go. Okay, so you see it ran the assembler for a boot sect here. It moved it into this file, ran it, moved it into this file. So we should have our os.bin in our file here. Well, it moved our binaries into here and then it ran it. Okay, so we'll have all our binaries in here, which is what I wanted. And it made it, and then we can run box once again just to make sure it still works. And it does. We're good to go. Okay. So that is basic Makefile use, and then we can just run makeOS whenever we want to create all our stuff, and it'll be good. Now this does still require, if we're putting more include files and stuff inside of our ASM files, you know, we'll have to put them in there. But as far as the overall building, this will make everything. I could even make a build folder and put the Makefile into there, but I can do that later. I don't really feel like it. I've spent long enough on this. So I want to get to the meat and potatoes, as it were, of this. And get to building a basic little file table, file system, kind of, not really, but that's all right. So how am I going to go about making a little basic file table? I'm going to basically try writing just the bytes for a file name and a sector that it should be located at on our boot disk, as it were. And then later I'm going to take user input to input that file name, and it'll try to load the file or load the program or whatever as it is. So if that didn't make sense, I'll explain it in a second. We're going to go back to our source. We have assembly and print. It'll go in the assembly source because we're going to make an assembly file. So we have these right now. So I'm going to make, or well, I can just, we're going to load a thing. I'm just going to call it filetable.asm. Filetable.asm, basic file table made with, I'm going to use DB, maybe DW to find a word and stuff if it works out a little bit easier. But right now I'm just going to do it all with DB. Basically, I'm going to write a giant string, which just has file or program names and like a dash or something, dash or hyphen, and then a sector number or just a number where it should be located at on the disk, so that if I want to load this later, I can read our file that we make, take in that file name, and then get the sector number it should be associated with in the string, and then load that sector from the disk so that we should hopefully go to our file. This won't be verified or anything. This is just a thing that we assume will be true because we're just writing it in a file. But later I can make maybe a memory manager or something that'll say actually where these are. But as far as for that working for the start, as far as any memory management, I'm just gonna probably make like a file browser, and it'll just read this table that we make and then just list the programs and where they should be located at on the disk or in memory, and it'll print that to the screen. That's all I'm gonna do with this for now. But yeah, exciting, right? Not really? Okay, that's all right. Basic file table made with DB. Strings consist of, let's just start it with like a bracket. I think I saw something where the guy started with brackets, so I'm just gonna do that to know where to start and end. So it'll end with these brackets. String consists of starting brackets and then file name dash sector number, and then maybe like a comma or something. I need to separate it somehow. I don't think space delimited would be the best, so we can just, you know, if we don't want to put commas in our names, at the moment we won't. I'm gonna assume we don't, so let me do file, I'll do like file name 1, file name 2 sector number. All right. And then that'll be the end. So that's basically, we're just making a big string of that. So let's define bytes. What do we want to do for our first file? We can make like a little calculator thing, I guess. It doesn't really matter. We'll just do that. We'll call it calculator. We'll call the file calculator. We'll do a dash. And what sector do we want to put it in? We're going to have our file table here. I'm going to do as the second or third sector as in our boot disk. The first one will be the boot sector because it has to load first. The second one, I can make the file table, I guess. And then the third sector, I can make our kernel. We're going to load all three from the boot sector and then jump to the kernel, jump to the OS like normal, like we're doing now. So this one we can make, this file table will be located in the second sector, but the program that we're going to write, our fake calculator at the moment that we'll write later, we can put into like the fourth sector of the disk, say. So I'll put in like 04. We'll just put in this calculator 04. And we'll put in another thing just for testing. We're not going to use it, but we can use it for testing at the moment. A file that doesn't exist, I'll put in program 2, whatever. Say we'll put it in the 6th sector on the disk. We're not going to at the moment, but we're just going to do this right now. So we have this file here, which is filetable.asm. If we run FASM on it, all right, it should make a binary called filetable.bin. And to see the results of that, we can open our file table. It should switch. I didn't want to open that. So xxd filetable.bin. So that shows the code. So these are the hexadecimal bytes, the machine code that makes these characters, because we're just writing ASCII characters to the file. But we should be able to read and compare against, you know, the character. We should be able to read this and be like, put the first character in AL and compare it to bracket, and it should still work, which is what I wanted. That's what it looks like. So, okay, so what we're going to do now, since we have this written, we're going to open our boot sector file, because at the moment we're only reading, well, this is assuming they're already in the file. We're only going to our kernel. Oh, okay, we'll just use cat. We'll concatenate. What we're going to do is concatenate our bootsec.bin and then our file table to make it the second sector, and then we'll concatenate our kernel.bin. So we'll change our makefile for that, but we want to read. If we make the kernel the third sector, we're going to have to make it third sector 3 instead of 2, and then we'll read 1. And that should be all we need for here. I want to also move the file table into memory so that we can use it. So actually, yeah, I'm going to still read 2. This will be moving the file table because we're going to make the file table the second sector. We're going to read it into 1000 is fine. Yeah, we'll read it into 1000. We just need to redo all this, which means I need to remake the disk load file. I need to put this code into a separate file to make it easier to work with, but we won't do that at the moment. Up here, I'm gonna put in read file. I'm putting it on caps just for me to know at the moment. Read file table into memory first. All right. And then we're gonna read our OS into memory. Read kernel into memory second. Let's do that. All right. Let's sector to memory. Our kernel we're gonna load to hex 2000 because hex 1000 will now be the file table. Starting sector to read will be 3 because we're gonna put the kernel now as the third sector in our boot disk. Only gonna read 1, we'll just do that again. Very simple. Then we're gonna move to 2 because our kernel will be loaded to hex 2000. All right, let's do boot sector. No, not boot sector. Sector padding. Magic. With an exclamation mark because we're excited, yes. Early in the morning excitement. If you're not asleep from my lack of inflection, monotone voice, well, maybe you're excited, and we'll put in our boot sector stuff here. The birds are singing outside. I don't know if you can hear that, but it would be nice if you could. Times What do we do here? Times. Oh, look, using the mouse. Oh, blasphemy. 512 minus where we're at. $. Well, where we're starting at in the sector minus where we're at. Okay, db 0. Just pad the rest out with zeros. We don't really care. That just makes sure we're going to pad it out to the sector. Okay, let's change back to the shell. And we'll run FASM again on our file table. So we're good. That replaced that bin. Okay. So in our boot sector here, let's save it. Write and save it. We're going to load our file table that we just wrote to the memory location 1000, which is what we're doing here. Then we're going to load our kernel, which we're going to make into the third sector on our boot disk, into memory location 2000. And then we're going to jump to it, and we should be good. Okay. So what I need to do is go back to our Makefile, which should be in our bin here. All right. We're going to open our Makefile. So now what we're going to do is add the file table into here. I'm going to add it after the kernel, so I'll just do it here to be consistent. Yes. Bootsect. So I'm going to put it here. We're going to do create file table. File table.bin. How do we want to make this? We want to run FASM on our source assembly. File table.asm, not .binary. And then move that file. You can make variables within the Makefile to hold, you know, long path names and stuff or whatever. You can make variables in this and use them in the Makefile. I'm not at the moment. I might later. But yeah. File table.bin. We're going to move it into this current folder. Okay. And in macOS, we're going to use, to move our file table into the second sector, our kernel into the third, we're just going to put the file table, bam, right smack dab in the middle here. And it will do this, which is padded out. This file, the file table binary, which is now padded out into the end of the sector, and then the kernel, which is padded out to a sector. So this will be 1, 2, 3 into our OS. And yeah, we should be good. Should hopefully. So I'm going to make clean and then make OS. Symbol already defined, read disk. Oh, so we have read disk twice in there. Yep, that's true, we do. Recipe for target failed. Okay, so we're gonna have to redo our, it's not in there. There we go. It read what I wanted to do. Hey, jump carry read disk. You gotta redo it again. Oh, we'll just rename it 1 for the moment. Read disk 1, read disk 2. Let's just do that. So that we don't confuse it and be like, hey, you put this thing 2 times. What are you doing, you idiot? We'll just do that. Hopefully that'll work. And that's the assembler file. So we don't have these in the moment. So we did it again. So it ran for the boot sector and then the file table, FASM, and moved it. And then this one. What we could do is put enters or new lines into our Makefile so that this would separate out in the output here. But, you know, I'm not going to do that at the moment. What did happen, though, is we made the file. See, we have our file table there now, which is nice. Our os.bin. If we do xxd on the os.bin, we'll see in the middle, this is the end of our kernel here. Here's our file table, which is the sector after. See, we have our boot sector padded out. Here's the last 512 byte here. Then here's our file table. So we have our characters here in the middle. And then this is our kernel. We have this code, which just boots and says, hey, welcome. So that's coolly dealio, right? Probably not cool at all for you, but I don't really care. I think it's cool. So, okay. We have our os.bin. We still have our box here, right? Yes. So if we run box, the same thing should happen. It should be all right, since we're now loading to 2000, which we loaded our kernel at. This hopefully still works. Hopefully, I say. And it does. Okay, I'm just making sure we load it to the right location. All right, so everything is still as it was. We just added a file table. So I want to make a basic like menu here. And then if the user chooses a menu option, it'll go, you know, to that option and load it. Or I can make a shell, which will just be any general thing. Or I can do both, which I'll probably end up doing. I'll end up making a user menu, which will have like options here, maybe 1, 2, 3, or I'll make it letters like a Option F will be like load file browser, load the file table. Option R would be run or something. C would be calculate, you know, stuff like that. Or, yeah, I'll just start off with the file loader browser. You can choose option F, or I can have a line at the bottom, like a traditional terminal window, and then you can type in, I'll type in like, I don't know, run something or a program name, and it'll load it. And if the program isn't loaded, it'll give an error, stuff like that. That's what I want to move towards, so. And my coffee is done now, which is, you know, bittersweet moment. Sweet because it's blueberry, bitter because it's coffee, and also I don't have any more. I could also clean up and redo our print functions if we want to use them. So we're using print string here. I can move this into its own file, clean up our print functions, make them a little better with a refactor by using SI and load single byte or string byte, source byte, however it was, do stuff like that. So in our kernel, we have booted, welcome to KSOS. I want to make a little menu thing. So the easiest way to do that is either print multiple strings containing, or you can just put it all in one string. Although I don't think there's is there a continue line within FASM? Like if I write like in blasphemous Visual Basic, you can put like an underscore, and that'll mean what you type on the next line is continued, but this isn't, you know, VB, which I'm thankful for. This is assembly. And I like it a little bit more than VB for this, but I don't know if there's a line continuation character I can put, but for the moment, we're not going to worry about that. We're just going to put it all as one giant string, which is nice. So DB will be within test string. So XA and D will be CRLF, carriage return, and line feed. Continuing on the next line, we're just going to do, how many characters is this? 30, 1, 2, 3, so that's 33 characters long. I just wanted to put like an underscore thing for a little header, as it were, so 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3. So that'll put a little heading line under it. 0xA, 0xD. I'm going to put that twice to have two new lines, as it were. And then we're going to put our first menu option. I'm just going to call it, what I need to do is put quotes around these as well, or else it's not going to count it as a string. All right, so what do we want to call our first thing we're going to load? I guess we'll load the file browser first. We'll load our file browser into memory. We're going to print it to the screen. That's what we'll do. So I'll just have like an option F. We'll just do it the moment, and I'll call it file. I think I just called it file browser in my notes. Yeah, file browser or file loader. We'll do file in program browser / loader. We'll just do that. All right, and then another, for good measure, another new line and a 0. Okay, and then whatever the user types in, we're gonna have the user be able to type in stuff and take user input. Although at the moment we're just gonna do F. I can make a reboot option as well, but I can go over that later. How to reboot. Technically it'll be a warm reboot, but we'll do that later. We have our stuff here. I'm gonna clean stuff up first. All right, we save this file, right? I just did, all right. Let's make it again. Let's run box. See, look, our development is much faster. So there we go, kernel booted. Welcome to KSOS. File and program browser loader, and then we have a little blinking light thing, which is nice. So we're gonna have the user be able to type, and if we type in F, it'll load our files. It'll loop through our file table and then print them to screen. That's what I'm gonna make next. So that's cool. We got a little string going. Hey, we're getting somewhere, guys. It's really slow going, but listen, it's working. We're getting somewhere. And I got light coming through the window now, so that's nice. Let's allow the user to type in stuff. Let's do that, which will be after we print the strings here. Let's put a little thing here. Print menu heading or screen heading. Let's just do screen heading. Print screen heading and menu options. All right. Alt the CPU. This will be the end of the program, so I'll put end program. Okay. And also going to do CLI clear interrupts instead of jump $. So after we print the screen and menu options, what are we going to do in our kernel? We're going to allow user input. So there is a get keystroke BIOS interrupt, which is int 16 and AH equal to 00. That's all you need is AH 00, int 16. It'll get the keystroke, it'll wait for a user to type something in. You press a key, it'll get that keystroke, and it'll put the character that you typed, if it was a character, and it'll put it into AL. So then if you want to print to the screen to show the user type something, you can just use int 10 because AL will already be the character you want to type. So that's nice. But yeah, we'll use int 16. So let me do this. Get user inputs, print to screen, and choose a menu option that they entered. Choose menu option or run command. We'll do both. We'll do like a little shell here. So we can either choose a menu option, go to a menu or program, or we can run the program as like a shell thing. So we'll do that. User interactivity, yeah. But that'll be using int 16. We're gonna set AH equal 2, so let's move AH 0, or we can 0 out AX. We'll just do that, I guess. 0, 0, okay. And then call int 16, biosync get keystroke. All right, so character goes into AL. All right, so what this means is this will wait for a keystroke, and if you type something in, it'll be in AL. We'll do just a little thing here, just to prove that this works. Character's already in AL. BH is fine, BL is probably fine. We'll do this anyway. Rewriting, reusing code, always great. It's really good, guys. Move BH 0. So I want to keep getting the keystroke. Well, we just want to get the first keystroke and print it to screen to make sure that this works first. After this works, I'm going to put this in like a loop, and then we'll just keep typing what the person puts in. Keep printing it to screen. Then when they press enter, we'll check for the enter key, which I think we can check for 0D or 0A. It'll print like either one, or 13 or 27, whatever it was in ASCII and the decimal version for the ASCII code. We can check for the enter key, and then when the user presses the enter key, we can run whatever they typed in. So actually, let's do that. Yeah, let's do that now. I'll make a key loop, I guess. We'll get this. Yeah, let's move that above here. Actually, let's do this. Key loop. So we'll set AX to 0. We'll do int 16, or we get the keystroke. Biosync get keystroke AH equals 0. Character goes into AL. Okay, so we'll get the character into AL. We're gonna move this. We're gonna move this into BH, because why not? Compare AL to enter is what we're gonna do. And the enter key, I think we can just compare to 0D or a hex D. Did user press enter key? All right. And if they did, we'll I don't know. But first, let's print it to the screen. Int 10. All right. Print input character to screen. Okay, and then we'll compare what they did. I guess we can move this after. Let's do this. My mind keeps changing, which is awesome. I love it. Makes me feel schizophrenic a lot of the time, but that's okay. We'll compare it to D. If they did not, we'll do jump equal this to another thing. But if they did not enter, we're going to print the character to screen. If they did enter the enter key, we'll just jump to, I don't know, whatever option they entered. If they entered F, then we'll go to F. Press entered, we'll go to run, I guess command will do a thing. Let's do run command. If they did not press the enter key, we're going to have a loop down here called run command. If they did not press the enter key, then it'll just print the character to screen, and then we're going to loop and go to, we're going to jump again to the key loop and get the next character that the user is going to be entering. Okay. Loop for next character from user. Okay. So in our command we're going to run, we're going to compare whatever, they entered. This is not the right way to do that, though. We want to get what they entered. So how do we do that? How do we get what they entered? We'd have to put it into like a buffer or something, or a register, right? Print character to screen. Okay, if they did not enter it. Okay, so let's move whatever's in AL into some register we're not using. Let's move it into SI. Why not? Let's move it into SI. I guess we could clear SI or something, but index. Let's see if we can move stuff into SI. Move AL into SI maybe. I don't know if this will work, but I just want to store that the characters that the user is entering, I want to store them into SI here, so that we can read whatever's in here and then run the command that's in there, I guess. Otherwise, you know, the character that they enter is going to be overwritten every time that they enter one. Let's compare whatever we put into, after we move it into SI, we're going to add, is it add SI1? Is that what we do to move to the next byte? I think that's what we do. Yeah, add SI1. And then the next time we'll move it into SI plus 1 here, and it'll be good. Okay. So we'll compare whatever's in. Oh, we need to get what's originally in there though. Ooh, how do we get the start of SI at this moment? We need to push it, I guess. Can push it onto the stack. That doesn't sound right. Well, oh yeah, we can push it onto the stack before we do all this. There we go. Genius guy, genius. There we go. Store SI location on stack. Bam. To get user input command. Okay. Then we'll go to the key loop. So after we can pop SI to get the original location. Bam. Restore SI from stack. Should contain user command. Okay, then we're going to compare what's in SI. I think we can do this. I don't know if we can directly compare what's in here. We'll find out. But I'm going to want to compare what's in there to whatever we currently have. If we have a command, then we'll do that. Otherwise, I might eventually make like a table of commands or something, and then we'll compare to whatever's in that table and search through it. But I'm just going to compare at the moment. We'll compare it to F. And if they enter in an F and press enter, we'll go to the file table command. So, or well, maybe I'll just print a string. If they don't enter F, we'll do command not found or something, because we don't have a command for that yet. So compared to F, we'll say it's our file table command. Okay, then we'll run the file table command, or at the moment I'll just print a string. We're using SI for the string. Let's use something else. Let's use DI at the moment. If we can directly use DI, let's do that instead, because we're not using it yet. Let's not mess up SI at the moment. We'll just use DI. Okay. Compare to F. If it was equal to F, well, jump not equal, go something else. But if it was equal to F, we'll move into SI another string. Let's make some other strings. Instead of test string, let's call this something header. Call it menu. Let's call it menu string. Menu string. So where did I use test string here? Okay, so that should work there. So into SI, let's move another string that we write. What string do we want? Success string. Let's just call it success, and it'll be DB. We'll call it command ran successfully. We'll change this later, but we'll just do this for now. 0. Okay, and then we'll also make fail, success and failure. We'll just make command not found. We'll do the old Windows error handling style of a frowny face. Oops, something went wrong. Let's do that. Let's do that instead. Oops. Something went wrong. There we go, just like Windows intended. If we did enter an F, we're gonna move success into here, sub S. Move success, call print string. All right. Jump not equal. Fail. We'll just do, or we'll do not found. We'll call it not found. Call print string, and then after this we'll jump to end. Well, we don't want to call end program. End program. We can do this. It was just, there was one, I think it was npgm or something, was a label in FASM and you couldn't use it, but I think this one's okay. We'll find out. End program here. Otherwise we'll jump equal to not found. Oh, not found, we're gonna move into SI failure. That's what I just called the string, right? And we'll call print string. And then jump to, well, we don't need jump, we're already there. Okay. We're gonna have our menu load. We're gonna take in what the user enters. When they press the enter key, we're gonna just compare it to the letter F at the moment. Later we'll compare it to a list of commands that we have. I guess we'll compare it to the file table. We're gonna print that to string, but I'm just taking in user input for now. This is a test for that. Compare what the user entered. If they entered in an F, it'll print a string. If they entered in not an F, they'll do another thing. And we'll see if this loads. It's probably won't work at all, and I'll get an error right now. I did not. I have these already made, so we need to do make clean first. All right. Yes, it did not like that. Operand size not specified. I want to compare it to the letter F. Can I not do that with the source and destination indexes? I might not be able to, actually. I can probably store them into there. But I did move it into there successfully. I just can't do this. Okay. So what I can do, though, is move into AL what is NDI and then compare AL to F. I should be able to do this. I think that'll work. So did it make clean? Yeah, I want to do that again. Okay. Okay, that worked. So we'll see if this works. It probably won't, with my luck. And yeah, it is not working. That's good. Halt instruction. Nice. Oops, something went wrong. Well, at least it told me something went wrong. Now we get to start our debugging adventures. Oh, always fun. Always fun when you can't type anything in right as well. Okay. Okay, guys, this is the next day after work. I debugged a bit. I just didn't want to record what I was doing. And I found a couple other small things to make this work a little bit better, so I'll share those now. I found there is a line break, a line continue, whatever character in assembly, or at least in flat assembler. You can use the backslash here. Because it's leaning back, it's a backslash, right? But you can put that and then it'll go, but it'll break the line, and this will be counted as one string. So I put another header line above, and then the line, then another header line below, new lines, and then this, and this is all one string for this DB for the menu string. So that's nice. You can split lines like that if you want. So for the reason the screen went black instead of blue and was not working was because I had int 16, which is decimal 16. You need hex 16, not decimal. 16H, hex 16 makes that work right to get the keystroke and weight. I added a get input label here. I added a command string variable. I just set it empty because we're going to put stuff into it. So after I did the command string, I put a get input before the key loop, and I'm moving command string into our destination index register, our DI. So that DI points to the memory location that command string is at. Then, you know, I get the keyboard input. I'm moving 0E into AH to print out the character. If we don't, press enter, comparing it to enter. If we did not press enter after the user inputs a command, then we will move the character that will be in AL from int 16 AH0. We're moving that character in AL into DI, which effectively moves it into this command string location. So the first byte in command string at this point will be the first byte that the user entered. Then I'm going to increment DI. I think I could do add DI1. I think I can do this. But I don't know. I did increment for some reason because it's shorter and I like short things. I don't know. I think it looks a little bit cleaner. Just increment DI to move to the next byte in memory. So that will be pointing at the second byte at command string now. And then we jump, loop for the next character. So eventually the user will enter in all the string that they want, press enter. We'll go to run the command. When they press enter, jump equal. Then I'm gonna null terminate the string. I don't need to do this, but I'm just doing it now, just in case I want to use it later, which I probably will. Just null terminating it. Then I'm gonna move command string, the memory location at command string. If we move DI, we'd be pointing to whatever the end is because we were incrementing it, but since this was the original memory location we moved into DI, we can use it and just get the string now, which will contain all the bytes that the user entered. So that's good. We're going to move the value at the first byte that command string is pointing to. So the first byte that was entered, we're going to move it into AL. At the moment, I'm just doing, one menu option here, which will be F for the file browser loader. So I'm comparing the first byte entered to F. If they didn't enter F, then we're going to our failure string, we're going to print it to the screen, and we're going to go back and get input for the next command or string that the user enters. But if they did enter F, we're going to go to success. If they entered N, we are going to end our program. Show that this works. I did make clean and I did make OS. So run box. So we have our fancy dancy header lines here. So we have a nice actual header. We have F here. So if I enter in something that isn't a command like J, it'll say something went wrong. Go to the next line. If I enter in F, the command was ran successfully, and if we enter an N, it'll end the program, which I don't have a string for it, but... Oh, actually it won't. Oh, it won't end the program. Nothing will happen. Anyway, but you can enter in, see, you can get user strings now from whatever they entered. I did not do this right. Oh, it goes to not found before it goes to there. Duh. Okay, anyway. Anyway, this works. Just wanted to show that this worked. You can get user input with BIOS INT hex 16 or 16H with AH register set to 0, or the AH part of AX register set to 0. Then you'll get the key input, which will be an AL, and I'm just printing that to screen each time. And if they enter in something that matches a command that we have set up, which I could probably put into a separate thing. Well, we'll use the file table with this soon. At the moment, I'm not. Eventually, we will. This is the first step to that. But yeah, that's where we're at now. The screen will keep going if we do that. I don't have a reset at the moment. I guess the next command I can put in will be like a reset, and then we'll re-show the menu in the screen. Anyway, this works for now. This episode's probably went on far too long and rambled on. I like how I end it with fixing something every time, but oh well, that's the development process, right? Hope you guys enjoyed. If you did, let me know. If you didn't, let me know. Either way, thank you for watching. Have a nice day. I'll see you on the next one.